Hi everybody, welcome to another mock interview with Exponent. Today we're going to be doing a software engineering question with Rohan. So before we dive in, Rohan, would you like to introduce yourself?
Yeah, sure. Thanks. I'm a former software engineer from Flipkart. I was a backend engineer there, working at the payments team, and I'll be joining a new company soon.
Sounds good. Thanks so much for being with us today, Rohan. So the question today, if you get a list of non-negative integers and a target number s, and two operations, plus and minus, how many ways could you assign an operation to each of those numbers such that the sum of those ends up being the target s?
Okay. So there's an array, and I have to assign signs negative and positive.
Exactly. One, either a negative or a positive to each of those numbers.
And these numbers in the arrays, they are positive numbers, non-negative numbers, right?
They're non-negative, yes.
Okay. And is there any range of the numbers of the array?
So the constraints you can work with are that that array, the size of the array is never going to exceed 20. So you're only getting a maximum 20 numbers. And then the sum of those numbers, say they're all positive, is never going to exceed 1,000.
So here we have this array, for example, 1, 1, 1, 1, and the target sum is 3.
Mm-hmm.
So basically, we assign, let's say, 1 here, 1 here, 1 here, and minus here.
Mm-hmm.
Then it will be like 4 minus 1, 3.
Mm-hmm.
Similarly, we can maybe move this minus sign here. It will be 3. So similarly, like we can move minus sign to every this thing.
That's right.
And it will be 3. So I think there will be 1, 2, 3, 4, and minus 1. So there will be total 5 ways in which I can assign signs in this
Mm-hmm.
array, right?
Yes.
Yeah. Okay. So basically, I think the brute force way, or the most basic way to approach this problem would be just to try all possible ways to do this. So for example, if you have so you can go one by one
Mm.
to all these numbers, and assign assign to them. So if we choose this one, assign a minus to this one.
Mm-hmm.
So one choice can be this, or another choice can be if you don't assign minus to this, and then recursively we can call move to the next number, and again do the same thing, assign minus to this number or not. And finally, at the end, if you reach the end, and if your sum is the target sum, then you can increase the count. You can keep a count variable, and you can increase the count at that point.
Okay.
So I think the most basic brute force way could be this. But I think in this, the time complexity will be big of uh, 2n, because will be recursively calling at every choice, at every index. Uh, so
So are you starting at a default positive for all of them?
no, so starting at the 0th index, okay.
Okay.
Uh, Starting here, and here will make two choices. So in first choice, you just take this as 1. In another choice, you assign negative to it,
Okay.
and then you move to the next index, and so on. You do till the end, and if you are able to reach the sum 3, then you increase the count. Otherwise, like you just return, you don't increase the count. That is one way to do this. If we like see this, so what we have is like, let's say this and this.
Mm-hmm.
So these are like two subsets, and what we are doing is like subset 1 minus subset 2 is sum s. So we need to like find number of subsets such that their difference will be the sum.
Okay.
So if we like let's say we call it s1. So s1 minus s2 is equals to s. So that's what we want. Uh, so if we see like let's say s1, so if we see like s1 plus s2, the sum of these two subsets will be like basically one second. So sum of s1 and sum of s2, this will be the like sum of all the numbers, right?
Mm-hmm.
So 1 2 3 4 and 1, so 5. I'll just call it nums. So this will be and we need to find this. So basically, we need to find the like number of subsets such that difference between them is s.
Okay.
So we can like just call them to equations, and like we can just add them. So if you add them, then S2 and S2 will cancel each other. So it will be like 2 sum S1. So basically, the sum of subset 1 will be like equals to this, basically. Sum plus the given sum plus like sum of all the numbers by 2. Essentially, what we are doing is we are reducing this problem to a simpler problem where we have to find the number of subsets such that their sum is equals to this, right? We
Mm.
need to find like number of ways we can form S1 such that their sum is this. So I think this will be a simpler problem to solve than that one. Uh,
Okay.
yeah, again, like this. So like, should I start with the like code?
Can you, so we've arrived at what you are simplifying the problem to. So what is your approach to finding this set now?
So we have like a sum, a number, and we have
Mm-hmm.
like an array. So
Mm-hmm.
in that array, we have to find like how many ways we can form that sum using that array, right? So
Yep.
let's say like this array. So how many ways we can form this sum? So if this sum is like let's say 3, so maybe 1 2 3 4 5 ways we will be able to maybe find that. So given a sum, so it will be again like this, that you have a sum. So at each point you will go to a number and say like if you are including this number or not, if you are including this number or not, and like you'll make choices again. uh, so
Yeah, let's walk through it step by step as if you're running the algorithm right now.
you are at the starting of the array,
Okay.
index 0, and what you're doing is you're deciding whether you want to pick this index or not. So and you have a sum, which is this, your
Mm-hmm.
target sum. So if you pick this index, then what you do is you recursively call, let's call this function fn. You recursively call this function with the index plus 1, and you subtract the current element from the sum. So let's say sum is sum minus the current this thing. So this is one choice, and you move. And another choice could be like you're not taking this number, or you're not choosing this number. So you just move to the next number without picking this number. So here you'll just not subtract this index from your sum, and just you'll move to the next index.
Mm-hmm.
So basically, like these will be your two choices, and these choices like will return like the count. Uh, so for example, so we are reducing the problem into
Okay.
smaller problems. So basically, uh, uh, these functions will give their respective counts, and then you can like just add their counts. So let's say it's a C1, it's C2, and we can just like return C1 plus C2. So it will be like this, and there'll be a base case.
Uh-huh.
So that will be like if you have reached to the end, or if you have passed the end. So if your like index is greater than, let's say, length of the nums, so then you just like return zero, because then it won't be possible. So like counter zero,
Mhm.
no subset is possible which gives this sum. Otherwise, like if your this thing uh, sum becomes zero, then you can like return one. So it means like your count is one. Uh, so you have found one subset such that it gives you the sum that you require.
Okay. Uh,
So it's basically it's again a brute force solution, but it can be optimized because so when we are like uh, moving further with a sum, so that part will be repeated like multiple times when you're like recursively calling it in the
mhm.
recursion tree.
Okay.
So like you have some like four, maybe it's coming in the starting, but you may like get that again in the mid or in the end. So
Yeah.
you're like solving the same problem again and again, so you can memorize it. That will be your optimized solution.
Okay. So let's this algorithm that you've come up with. Can we run through it with the small sample that you've set up over here with the array of size 5 and the sum 3?
Sum is like 3 plus sum of nums is 5 divided by 2, so it will be 4. So how many subsets do we need? Uh, like how many subsets can be there which forms this number?
Mm-hmm.
So if we like run through the this thing, so again like we'll start with the input will be like the 4 and the index will be 0.
Okay.
So uh, what we can do is like uh, we can first choice will be like including one or not. So let's say first choice we are including one, so we just move to the next index, and then our sum will be 3, and again like we are recalling this function with this, so again we go here and
Which function are you recalling right now?
this. So let's call it fn. We only have one function, let's call
Yep.
it f. So we are like calling fn, and it
Mm-hmm.
takes two things, index and sum.
Okay.
So we called it with 4 initially.
Mm-hmm.
It goes up to here, this line 17, and
Okay.
again it calls again recursively itself with 3, because we are including this thing. the current index.
Okay.
Again, similarly, like we will recall it with 2, uh, finally with 1, and finally like we will so after 3, 4, 3, 2, 1, and finally like we will reach 0. So
Mm-hmm.
when we reach 0, it will be like we have reached the end. So then it will return 1 on line 16. It's
Okay.
returning 1. So it will trace back here.
Yep.
And now like other choices not including this number. So we just skip this index, and so we again call it with 1. uh, and next time again like we goes to line 17, again it subtracts like sum, which is 1 from the value 1,
Mm-hmm.
and again it's 0. So again like it returns the int. So at this point like c1 and c2 both will be 1. So we will get like 2 cases here, and then like we will return those 2 cases back, and then like again we will be at like line 18 from 3. So here like we are skipping the number here.
Mm-hmm.
So it will be again like 3, and then like again it will 2, 1, 0, and like basically this part will repeat itself.
Got it. Okay. Sounds good. So I think we can move on to writing this up so that you can run this on any case. Yeah.
Yeah, that would be okay. uh, okay. So I'll just call it fn. Maybe I'll find subset. uh, so it we are taking an index, and we are taking the sum, and it's a function that will be calling from our main function, and will be passing this thing, that this thing. So this will be our sum, and index will be 0, and we also need our array.
Mm-hmm.
So these 3 things will be there. Let's start with the base case. So if index is greater than index plus 1, norms will be same, and here we are, this is the case we are including this current index. So that's why we will subtract it from s. So that will be this will be like same, except we won't subtract. Yeah, and then we can just return sum 1 plus sum 2.
Mm-hmm.
And so this is like again the brute force solution.
Okay.
So we not memoized, so we also have to like memoize. So maybe like a variable dp will be
Okay.
there. So instead of like returning this, what we'll do is so it will be like a 2D array, and we will just store the sum1 plus sum2 here,
Mm.
and this will be the sum, and this can be the index. So now here we'll add one more case. If we already have this, uh, so we will initialize this like as -1s to
Mhm.
know like if it's changed or not. And then like if it's not, then we can just return it. So we don't do the repeating calculations like
Yeah,
here.
sounds good.
Just call this one find subset from here.
Mhm.
Actually, we also have to create a function. Change signs, I'll call it. So it's taking the nums and the sum as. So now basically we have to do this thing.
Yep,
So
to find out what your subset is.
yeah, just call it total. And this should be even. So if it's odd, uh, basically this thing should be even. Because if it's odd, then it means like we cannot have such that if we change their this thing numbers, we reach the sum.
Can you say that again, please?
No. So basically this thing. Okay, once again I'll write that down and then
Mhm.
I'll. So this thing, right?
Yep.
S plus sum of all the numbers. So this should be even. If it's odd, that means that two sets are not possible, such that so initially we did this thing, right? Sum s1 minus sum s2 is equals to s. So that
Mhm.
was our initial problem.
Yep.
So if it's even, then it means like there are no like two sums like this. If
Got it.
it's yeah, so
Okay.
it should be even. If it's odd, then that won't be possible.
Okay.
So we can just like add a jack here with -1. Yeah, and we have our total. Now we can just call our find subset, and we also need to initialize this. So it will be 0
Mhm.
as uh, so we have two things, this s, and we have this thing. So it's the range of this. Yeah. So that will be our DP. That is our sum and nums and 0. Yeah.
Great.
Yeah.
Okay. Let's test this quickly.
Yeah, sure. Let's check the function again. It never like runs perfectly first time.
That's all right.
Yeah,
I know the
it
feeling.
never happened to me. Okay, let's see like what error. Yeah, we're not passing the parameters here.
You can erase the hello world if you want.
So one thing I think that's important that
Mhm.
we make is so this can only happen if the this thing is if the number is like smaller than the sum, right? If number is bigger than the sum, then it won't be possible.
Which number?
The current number at the index. So the current number at the index should be less than the this thing sum.
Okay.
Yeah.
So, can you give me an example of when this won't work?
So like if your sum is like 2 and number is like 3.
Okay. If your sum is 2 and your number is okay, I see. Then that so if you have an array that is 3 and 1, it's those two numbers and your sum is 2. Will this work?
Mhm. If your sum is 3, sorry, sum is 2 and number is 3.
Your the two numbers in the array are 3 and 1 and your sum is 2.
Sum is 2 and two numbers are 3 and 1.
Yes.
Yeah. Yeah. So obviously, like you cannot include 3, right? Because 3 plus something cannot be 2.
But 3 minus 1 can be 2.
Yeah, but we have reduced the minus problem to some problem, right? We are solving the sum.
Okay. Then what? So if you are given that case, 3, 1, and the sum is 2, what? And the question is,
We will just ignore the 3.
okay, got it. And so what will the final answer from your algorithm be for how many ways you can assign the plus and minus to those numbers to give you 2?
If 3 and 1 is there, so then answer will be 1.
Okay. And okay, so let's run that through this.
Because if 3 and 1 is there, then this sum, right? So we also need one more thing. Acha, okay, 2. So 3 and 1, 4 plus 2, 6 by 2. So this will be 3. So then in 3 and 1, we will be finding number of subsets whose sum is 3.
Number of subsets. Okay.
And there's only one subset like that, 3.
Got it. Okay. So can we run that? Can we run your code on that example?
Yeah, just one second. There's some problem, I think, in the code which I'm
Okay.
trying to figure out.
Think out loud when you're trying to debug your code. That'll help both you and me.
Yes. So like this TP, we are doing for length and this. So this should be fine. And total. So I think this change sign function is fine. These so s is equals to 0, then return 1. This is also good. This should be like this only. And if it's index, if index reaches at okay, it shouldn't be greater than equals to actually. It should be greater than.
Okay, let's run this now. Great. Okay, let's try a couple more cases. So let's try that other case that you were talking about, 3, 1, and the sum is 2. And let's see what that gives us.
So 3 and 1 and 2.
Yep.
Okay, it's giving 0. Okay, I'll just I'll just like print out.
That's fine.
0 is the current index. 3, 1 is the nums, and this is 2. It should have been 3 plus 1, 4 plus 5, 6. 6 by 2, 3. Okay, it should be 3. So S is 2, and some nums. Okay, we are passing it this thing, not total. We should have been passing the total here. We are passing S instead.
Yeah.
That's the problem. It should also be total.
Okay.
Yeah.
Great. Let's try that.
Okay, it's giving 1.
So it's giving you 1, and it's giving you 8 for the first one, right?
It's giving. No, it's once again. I'll remove the.
Yeah.
It's giving 5 for.
Oh, it's giving 5 at the bottom. Got it. I see that.
5 and 1.
Great.
It never like in the first try it never runs. Like I've never had an interview where
any code that you write is going to have bugs in it. The key is just being able to walk through those and figure them out. So, all right, what do you think changed in the space complexity between the brute force approach that you were taking before and the memoization that you applied?
So brute force, like we were not storing anything, right? Here we are storing these things. So here, like it's sum, basically this thing, a total into the length of the nums array. So LT, O of LT, it's in this case.
L being the length of the array and T being?
T being total.
Total. Oh,
this thing, line 26.
Got it. Okay.
S plus some nums. by 2. So this thing. So
Okay.
this into the length. So that will be our space complexity in this
Yeah.
case. In the first brute force, we were not using any space in our solution. So it was
Yeah.
just space used by the recursion stack, uh,
Okay.
which is like of number of possible these things
Got it.
choices.
Okay. I think this is a good place to stop. How about what do you think went well, and what do you think you could have improved?
Yeah, I think the time complexity is nice for the solution,
Uh-huh.
and so it's of total into length,
Mm-hmm.
complexity. In the brute force, it was 2 to raise to the power n. So I think the time complexity improved greatly.
Yeah.
The solution. I think we can further optimize it, the space complexity,
Mm-hmm.
because so this is like our top down approach, right? We can
Mm.
also go bottom up, building the solution from building the small solutions and combining them
Yeah.
to get to the bigger solution. So then we have to create a table kind of a thing,
Mm.
and then there we can do some more optimizations to improve the space complexity of the solution.
Do you think there will be a trade-off between the time and space complexity for that kind of solution?
No, I think time complexity will remain same.
Okay. Okay. So here's my feedback. I think you did well. Ultimately, I think the solution was very elegantly drawn out from initial brute force to that simple addition of the memoization step. I think that was really good. Um, I think it's always helpful when you're debugging things like this to just say it out loud. So even when you're going through the lines of code yourself, if you're saying them out loud, I know what you're thinking, and you're more likely to come up with what's wrong a lot faster. Um, and then it's always helpful for the small cases that you start off with in the beginning to very clearly walk through them. So you did well ultimately when you started pointing out the lines of code that you were hitting at different stages of your algorithm when you were just walking through it verbally. That really helps, just to kind of illustrate where you are in your algorithm and exactly what's going on. So if you hit any issues, you hit those pretty quickly and very clearly, so that the interviewer knows that you're on the right track to debugging yourself and getting yourself out of sticky situations. So yeah, definitely keep referring to those lines of code. That's very helpful. And yeah, I think you walked through the case pretty clearly at the end and managed to come up with a working solution. So this is really good, and good luck with your future interviews.
Yeah, sure. It felt like a real interview.
Well, I hope it was useful.
Like,
All right, thanks so much, Rohan.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching, and good luck on your upcoming interview.